So, in the previous class, we have seen Huygens wave theory, Huygens principle and modification of Huygens principle by Fresnel. Fresnel introduced the idea of interference of light waves, according to which the secondary wavelets interfere and in this way the wave propagates. So, we will see first here what is interference of light waves. So, interference of light waves means it is the phenomenon of redistribution of energy such that some regions get less energy and some region gets more energy. When light waves from two or more sources superpose. So, when light from two or more sources arrive at a place, then in that region some regions will get more energy and some get less energy. This phenomenon is called interference of light. Now, here energy, that is, energy is not created, not destroyed, it is just distributed. So, the region which gets no energy, the energy from that is distributed in the region where there is more energy. So, this is what interference of light waves. Now, already in electromagnetic waves chapter we have seen that light waves can superimpose, they carry energy, and let us see how this interference phenomenon occur in a mathematical way. Now, let us see, suppose this is a location P where we are interested in seeing how these two light waves arriving from two sources S1 and S2 superimpose and create redistribution of energy, that is interference pattern. So, let us denote the electric field coming out from this S1 wave, that is the electromagnetic wave. So, when an electromagnetic wave reaches here, so generally the electrical properties will dominate at P. That means the magnetic properties of this electromagnetic wave will not be dominant. So, the dominating field is E1. So, suppose the electric field due to S1 is given by E1 is equal to S1 sin omega 1 t plus theta 1, and the electric field component due to S2 is given by A2 sin omega 2 t plus theta 2. So, these two electric fields are because of the two waves coming from S1 and S2. So, now when they interfere according to the principle of superposition, E will be given as E1 plus E2. Now, we are interested in the distribution of energy. So, we must know how much energy this carries. So, energy, we will use this property that energy carried out by electromagnetic field is given by here energy density, that is we will call it I, intensity of light, or in electromagnetic waves we call I, in optics we call this as irradiance, is epsilon naught C E square. This E is electric field, this is the instantaneous field, that is E1 A1 sin omega t plus theta. This intensity varies with time. This is the amount of energy falling per unit area per unit time. This expression is there. Since this electric field is a vector quantity and this intensity is the quadratic function of E, we can write this expression as epsilon naught T E vector dot E vector. So this is the expression of intensity, that is the energy carried out by this E wave. Now here, when two waves at P arrive at the same time, then the resultant E is given by E1 plus E2. So in order to know the intensity at P due to S1 and S2, we will have to use E naught C, this E1 vector plus E2 vector dot E1 plus E2 vector. We have to use this expression. So we will get this as epsilon naught T times E1 dot E is nothing but E square, I will write, or E1 dot E, plus epsilon naught C times E2 vector dot E2 vector. Then we will get 2 epsilon naught C E1 dot E2 vector. Now the expression of the intensity at P, that is irradiance at P, constitutes these terms. This is the energy carried out by the wave coming out from S1. It is the individual energy carried out by S2 reaching there, and this term is called interference term. So we will write this as IT as I1 plus this as I2 plus this as I12, in bracket it is called interference energy. So what happens? Sometimes this energy is positive, sometimes it is negative, sometimes it is zero, depending on the path difference between S1 and S2, these terms will be there. So when this is zero, that means the intensity at P is the sum of the total intensities due to these sources. But we will see how this I12 depends on other factors. Now let us see I12 term, that is the interference energy. We have already seen this is epsilon naught C times E1 dot E2 2 times E1 dot E2. So we can write this as 2 times epsilon naught C. E1 is A1 sine omega t plus theta 1 dot A2, this is omega 1 sine omega 2 theta plus theta 2. Now we can bring this 2 inside. So this is the general trigonometric formula. We can bring this A1 A2 outside also, so that we can directly use, this is 2 epsilon naught C A1 A2 2 already we have brought inside it. We have brought 2 inside it. So this is 2 sin A sin B, that trigonometric formula. We will use this trigonometric formula. 2 sin A sin B is equal to cos A minus B minus cos A plus B. So using this trigonometric formula, we will get epsilon naught C A1 A2, that is now cos A minus B term. So this is cos A minus B is omega 1 minus omega 2 t plus theta 1 minus theta 2. This cos term, then again minus cos, next term is A plus B, that is omega 1 plus omega 2 t plus theta 1 plus theta 2. Now we have 2 terms, and this is minus here, that is I have split that interference energy into 2 terms. This is the addition of these two terms, we will get that I12. Now, we will get here 2-3 cases. Let us see case 1. Case 1. Now, if two waves of different frequency add up, what will be the result? That means if omega 1 is not equal to omega 2. So, you see, if omega 1 is not equal to omega 2, that means this term is finite. This is finite term. So, cos of time varying function, and here also this term will be finite. So, the average, if I will calculate the average energy, then this term will be 0, average of cos function when cos theta, where theta is changing, this whole is time varying. So, this average and this average gives 0. So, if omega 1 and omega 2 are not equal, then the average of first and the second term vanishes. As a result, I12 equal to 0. Average of I12 equal to 0. What does it mean? It means that when the two waves, interfering waves, have a different frequencies, then the interference energy will be 0, and simply the energy arriving at P due to the two sources S1, S2 will be simply added. So, there is no interference in such a case. Now, case 2, when omega and omega 2 is equal, this is very important point, very important point. When omega 1 and omega 2 are equal, that means this time varying factor, that this term becomes 0. When this term becomes 0, then this term is cos theta 1 minus theta 2. What about this term? They two are equal. So, this cos function is time dependent, and over a large time its average is 0. So, when omega 1 equal to omega 2, the average of first term is finite and non-zero, and average of second term is 0. This term gives 0 average, and this term gives a finite value, that is maybe 0, maybe not be 0. So, it is a finite value we will get. So, in that case, we will write I12 is epsilon naught C A1 A2 cos theta 1 minus theta 2. That is, interference energy is this much. This is very important term. We got when two waves, now interference, we can further refine our definition of interference, that when two waves of same frequency superimpose, then the redistribution of energy takes place, and this phenomenon is called interference. We will get here interference energy this. Now, here interference energy depends on theta 1 minus theta 2. That means I12 may have any sign which will depend on theta 1 and theta 2. Now, here I can introduce another point, coherency of two sources. That means if theta 1 minus theta 2 itself varies with time, that means my sources are incoherent, then again its average will become 0 and we will not get an interference. So, let us see how. So, now we see that the interference energy is I12 is equal to epsilon naught C A1 A2 cos theta 1 minus theta 2. Now, if theta 1 minus theta 2 varies with time, then again the interference energy will be 0. Will be 0. There will be no interference if theta 1 minus theta 2. Now what is theta 1 and theta 2? Theta 1 is the phase of the first wave S1. S1 was arriving here and from S2 wave was arriving here. So theta 1 was the initial phase of S1 and theta 2 is the initial phase of S2. Now if theta 1 minus theta 2 is time dependent, means where is which time, that means their phases initially some difference may be there, but that difference is not maintained. That means they are not coherent source. So if theta 1 minus theta 2 varies with time, then again interference will be 0. In this case, we say that the two sources are incoherent. So there is one technical term introduced, incoherent sources. So the essential criteria, thus the essential criteria of interference is 0.1. Omega must be equal to omega 2, that is, i.e. two waves must have same wavelength or frequency. Better word, use frequency. And the second point is that theta 1 minus theta 2 does not vary with time, i.e. the sources must be coherent. So with coherency we mean that the two sources, if any phase difference exists between them, that phase difference must be maintained constant. If that varies with time, that will give this I12 average equal to 0, and so there won't be any interference. So for interference, omega 1 should be equal to omega 2 and the two sources must be coherent. Now let us see how the total intensity will depend on the initial phase difference. So now let us see the interference, the total energy we got here as I1 plus I2, and that is another term epsilon naught C A1 A2 cos theta 1 minus theta 2, with this write as I1 plus I2 plus this term as I12. This is interference energy. Now this energy, this is time varying energy, that is instantaneous value of energy. We will calculate in another session that this is average energy or RMS value of this energy. So at that time I will get I is equal to I1 plus I2 plus 2 root I1 I2, where I1 I2 will be the RMS value of the energy. So this is here time dependent value. So the time dependent irradiance at the point P due to two sources we got to be I1 plus I2 plus I12, which we called interference energy. So this is what interference of light waves is. Now let us see Young's double slit experiment, where we will see how light interferes and shows its wave character in an elegant way. So now let us see that we have already seen that the essential criteria to produce interference of light is omega 1 must be equal to omega 2, first condition, and the second condition is that theta 1 minus theta 2 should not vary with time, that is coherency. The two sources must be coherent sources. Now how to create two coherent sources? We have two techniques. To create coherent sources. One is called division of wavefront. One method is to divide a wavefront and another is division of amplitude. Two methods are there, two techniques are there to produce interference. In this method, a source is taken, point source is taken, it emanates wavelets and it is divided by passing through two pinholes or two slits, or there are many different techniques to produce division of wavefronts. Similarly, division of amplitudes we can do by different techniques, and let us see how we can do so. So, in division of wavefront method, a single source is chosen and its wavefront is divided into two parts. So, there are many experimental techniques where this is used, just like YDSE. The first we will see YDSE means Young's double slit experiment. We will first see that. Then again it is billets split lens interferometry. So, here we use a lens, we will split it into two parts and each part will be assigned to divide the wavefront into two. So, billets, then Lloyd's single mirror, then Fresnel's biprism and others. There are many techniques to do so, numerous techniques are there. Now, in division of amplitudes, so when the interference of light waves takes place due to division of amplitude, then a number of phenomena are due to these things. For example, color of thin films. The brilliant reflection of light from a compact disc is because of this interference due to division of amplitudes. Next, Newton's rings. So, these are phenomena which happen because of the interference of light due to division of amplitude, and here we will see. So, one by one we will go through it. So, first we will see what is Young's double slit experiment.